This is the Edexcel higher tier, paper 2 calculator paper from June 2024. Question 1. ABC is a right-angled triangle. Work out the length of C to B. So we've got all three lengths in the question. It is Pythagoras. A squared plus B squared equals C squared. We're finding a shorter length. So that's going to be A or B. C is the hypotenuse. So it's x squared plus 10 squared equals 19 squared. Take 10 squared away from both sides. So it's going to be 19 squared take away 10 squared. And then we're going to square root the answer. So 19 squared take away 10 squared is 261. So it's going to be the square root of 261. We want to give our answer to three significant figures. 16.2. Question 2. Write 90 as a product of its prime factors. So we're going to start with 90. We're going to break it down. So it's 2 times 45. 2's prime. 45 is 3 15s. 3's prime. And 15 is 3 5s. So we've broken it down until we've just got prime numbers left. So we've got 2 times 3 times 3 times 5. So you can either write 2 times 3 squared times 5 or 2 times 3 times 3 times 5. A is 2 squared times 3. B is 2 times 3 squared. Write down the lowest common multiple of A and B. So the lowest thing in both their times tables. So A and B, in common they've got a 2 and a 3. A's also got another 2. B's also got another 3. So their highest common factor, which isn't what we're working out, is 2 times 3, which is 6. Their lowest common multiple is all of them times together. So 2 times 2 times 3 times 3. 2 times 2 times 3 times 3 is 36. Question 3. The number of hours that some machines take to make 5,000 bottles is given by H is equal to 72 divided by N, where N is the number of machines. On Monday, 6 machines made 5,000 bottles. On Tuesday, 9 machines made the bottles. The machines took more time on Monday than on Tuesday. How much more time? So it's just a substitution question. On Monday, the number of hours is 72 divided by 6, which is 12. On Tuesday, the number of hours is 72 divided by 9, which is 8. So how many more hours did they take on Monday? 12 take away 8 is 4. 4 more hours. Question 4. There are only red discs, blue discs, and yellow discs in a bag. There are 24 yellow discs. Mel is going to take a disc at random. The probability of it being yellow is 0.16. And then we've got the red discs to blue discs ratio, and we need to know the number of red discs. So we're going to use the yellows to find out how many discs are in the bag. So 0.16, 16% of the total is 24. 16% of the total is 24. So the total is 24 divided by the 16%. 24 divided by 0.16 is 150. So there's 150 discs in the bag. 24 are yellow. So we've got 126 that are red and blue. and we need to share them in the ratio 5 to 4. So 5 to 4 is 9 parts. So 126 divided by 9 will tell us how many discs are in each part, and that is 14. So it's 5 14s, 70, and 4 14s, 56. So that's red and blue. The question said how many red discs are there? It is 70. Question 5. Complete the table of values for y equals x squared minus x. So I'm just going to do it in the calculator. I'm going to do something squared minus something. And I'm going to use brackets. So something squared minus something. I'm just going to type in the number into the brackets in place of x. So I've got 6 for 3. For 1, we have 0. And you can see a symmetry here. It should be 2. So we've got 0, 0, 2, 2, 6, 6. So for negative 1, we get 2. So on the grid, draw the graph. So negative 2, 6. Negative 2, 6 is here. It was negative 1, 2. 0, 0, 1, 0, 2, 2, and 3, 6. We need to join them with a curve. An x squared graph, a quadratic graph, is curved. Something like that. And we've got a part C. Use your graph to find estimates for the solutions of the equation x squared minus x equals 4. So where is x squared minus x equal to 4? It's going to be somewhere between the 2 and the 3 and the negative 1 and negative 2 because it went from 2 to 6. So where is it equal to 4? Let's draw a straight line along where y is equal to 4. And it should be symmetrical. My graph isn't quite. So on this side, it looks like I've got 2.55. But on this side, I've got minus 1.5. So that's not perfect. I'm going to give my answers as I've got them on the graph. So I've got minus 1.5 and 2.55. I think I should have got minus 1.6 and 2.6, but there's a range of acceptable values and these are within them. So you can just read off the ones you get on your graph, and as long as you've drawn a fairly good graph, they should be within the range of acceptable answers. Question 6, Andy, Luke and Tina share some sweets in the ratio 1 to 6 to 14. Tina gives 3/7 of her sweets to Andy. So 3/7 of, so times 14, that's 6. You can use the calculator if you prefer. So Tina's given 6 to Andy. So Andy's getting 6 more. So he'll have 7. Tina's getting 6 less. So she has 8. Tina then gives 12.5% of the rest of her sweets, of her 8, to Luke. So 12.5% of 8. Now 12.5% is an eighth, but 12.5% of 8 is 1. So she's given 1 sweet to Luke. So that would make it 7. Luke's goes up by 1. Tina's goes down by 1. 7 to 7 to 7. Tina says now all 3 of us have the same number of sweets. Is Tina correct? Yes, they all have 7 parts. Question 7. ABCD is a quadrilateral All angles are measured in degrees. Show that ABCD is a trapezium. So in a quadrilateral, all the angles have to add up to 360 degrees. So if we add up all of these, we can find x. We can make it into an equation. So 4x plus 15 plus 4x plus 8 plus 2x plus 15 plus 3x minus 3 equals 360. Collect the like terms. So I've got 4, 4, 2 and 3. That's 13 x's. 15, 15, 8 and negative 3. So 38 take away 3 is 35. Again, remember you do have a calculator. You can type this into. Take away 35 from both sides. And I am going to pick up the calculator. So 325 divided by 13 is 25. So x is 25. So if x is 25, what are these angles? 4 25s is 100. That's 115. 108. 2 25s are 50. So that's 65. And I've got 75 take away 3, 72. So why is ABCD a trapezium? It's because we've got parallel lines. So co-interior angles add up to 180. So these add up to 180, these two sets, which means B to C and A to D are parallel. So B to C and A to D are parallel because co-interior angles add to 180 degrees. So because we've got a set of parallel lines, therefore it's a trapezium. A playground is in the shape of a right-angled triangle. Dan makes a scale drawing of the playground. He uses a scale of 1 centimeter to represent 5 meters. The area of the playground on the scale drawing is 28 centimeters squared. The real length of Q2R is 40. Work out the real length of P to Q. So we've got an area of 28 centimeters squared, and we've got a scale of 1 centimeter to 5 meters. The real length of Q to R is 40 meters. So if we do 40 divided by 5, that's 8. So Q to R is 8 centimeters. We can find P to Q because the area of a triangle, so half base times height. Let's call that x. Half base times height equals 28. So 4 x's are 28. X is 28 over 4, which is 14 over 2, which is 7. So we've got a base of 7, a height of 8, which makes an area of 28. What's the real length of P to Q? So if it's 7 on the drawing, it's 7 times 5, which is 35 meters. Question 9. A number n is rounded to 2 significant figures. The result is 7.3. Write down the least possible value of n. So if it's been rounded to 7.3, it must be in between the two midpoints, 7.25 and 7.35. So the least possible one is 7.25. Layla says the value of n cannot be greater than 7.349 because 7.350 would round up to 7.4. So if we just name something bigger than 7.349 that would still round to 7.3, we can show Layla is not correct. So no, Layla is not correct. We can go to 7.3499, which is greater than 7.349. And 7.3499 would round to 7.3. So n can be anything all the way up to 7.35, but that includes 7.3499999999 going on forever. Question 10. The diagram shows two right-angled triangles. All lengths are measured in centimeters. Given that sine A is equal to tan B, work out the value of x. So sine A is SO, opposite, over hypotenuse. 7 minus 2x over 8. And tan B, tan is TOA, opposite over adjacent. 1 plus x over 4. So if these two are equal, we can just write 7 minus 2x over 8 equals 1 plus x over 4. And then we've got an equation to solve to find x. So let's multiply both sides by 4 and both sides by 8 to get rid of the fractions. 4 times 7 minus 2x equals 8 times 1 plus x, which will be 28 minus 8x equals 8 plus 8x. Get rid of the smallest x, so plus 8x to both sides. 28 equals 8 plus 16x. Take 8 away from both sides. 20 equals 16x. Divide both sides by 16. X is 20 over 16, or 10 over 8, or 5 over 4, or 1.25. Remember, you do have a calculator, so you can just type that in and get your answer. Question 11. We've got a cumulative frequency question. We've got 60 parcels. Complete the cumulative frequency table. So 0 to 2 is 7. 0 to 4 is going to be the 0 to 2 plus the 2 to 4. 7 plus 21 is 28. 0 to 6 is 0 to 2 plus 2 to 4 plus 4 to 6. So add on the next one. That will get us to 43. 0 to 8, add on the next one, 54. And then all the way to the end, all of them are 60. On the grid opposite, draw a cumulative frequency graph for your table. So we had 2, 7, then 4, 28, 6, 43, and 8, 54, 10, 60. And then I'm going to join them up. I'm going to join them with straight lines because I find it easier. But you can join them with a curve. A curved line is also okay. Use your graph to find an estimate for the interquartile range. So we have 60 parcels. So a quarter of 60 is 15. So that's the lower quartile. The lower quartile is somewhere around there. The upper quartile is going to be at 45. 3/4 of 60 is 45. Okay, so we've got a lower quartile at 2.7, an upper quartile at 6.4, So the interquartile range, 6.4 minus 2.7 is 3.7. And again, there'll be a range of acceptable answers for that question. Use your graph to find an estimate for the number of these parcels with a weight greater than 7.4 kilograms. So we're going to find 7.4, so 7, 7.2, 7.4. There. Go up to the line. Then along. So I've landed on, I think, 51. 51. So how many are greater? Greater than that. That's 51 to 60. That is 9. 9 parcels greater than 7.4 kilograms. And again, you can check back on the table and see if this makes sense. So, yeah, about 9 would weigh more than 7.4 kilograms. Question 12. F is inversely proportional to d squared. So we need to change that into a formula. So change this sentence into a formula. F equals k divided by d squared, where k is just a number that we need to work out. So F is something divided by d squared. So inversely proportional means something divided, and directly proportional, something times. So F equals k over d squared. F is 3.5 when d is equal to 8. So what's k? K is going to be 3.5 times 8 squared. And I'll just type that into the calculator. It's 224. So what's the formula? F is equal to 224 over d squared. Part B, find the positive value of d when f equals 10. So I'm changing f into 10. So 10 is 224 over d squared. We need to find d, so times by d squared times by d squared, divide by 10, and square root. We're only interested in the positive square root, so we want square root of 22.4 to 3 significant figures, 4.73. Question 13. On the grid, shade the region that satisfies all of the inequalities. So they're all greater than or less than equal to's. So they've all got an or equal to. So we're going to draw solid lines. X is less than or equal to 2. So x is equal to 2 everywhere along this line. And we need it to be less than. I'll put a little arrow where it's less than. That might help us out later. And y has got to be bigger or equal to negative 3. Y is equal to negative 3 all the way along here. It's bigger going up, so up there. Y is less than or equal to 2x plus 1. So I'm going to draw the graph of 2x plus 1. I know it's got a y-intercept at 1. So the y-intercept's at 1. And for every 1 it goes across, it goes up 2. That's a gradient. So along 1 up 2. Goes back 1 down 2. So it's like this. So I'm just going to draw that one on as well. And 3x plus 2y is less than or equal to 6. That one is going to be a lot harder. Wait a minute. Y had to be less than that one. Y is less than going down. So it's in this direction. We just need to figure out this last line. 3x plus 2y equals 6. So let's do a little table. When x is 0, what does y have to be? For 3x plus 2y to equal 6, it'll be, if x is 0, we'll have 2y equals 6. Y would have to be 3. If y is 0, 3x equals 6, x would have to be 2. And then I'll do another one. I'm not sure what point would be a good one to do. Let's have, well, we've gone 0, 2, let's have 4. So when x is 4, 3x's 3 4s are 12. So take 12 away from both sides. So 3 4s plus 2y equals 6. 12 plus 2y equals 6. 2y is negative 6. Y would have to be negative 3. And that follows the pattern. So we've got 0, 3. 2, 0. And 4, negative 3. So draw that one on as well. And x and y have to be less than, lower. So it's down and left, that way. So we're shading the region that satisfies all of them. It's the middle bit, it usually is. Is it called R? And I can check using a point. So I've got 0, 0 in the middle here. 0, 0 is in the region. So it should make all of my inequalities true. Let's check. So 0 is less than 2. 0 is greater than negative 3. 0 is less than 1. And 0 is less than 6. So that looks good. 14. The graph shows the velocity of a car in meters per second, t seconds after it starts to slow down. We want an estimate for the acceleration. So we've got a velocity time graph. The gradient is the acceleration. So the gradient of the line is the acceleration. It's an estimate because we've got a curved line. We need to try and work out the gradient at a point. So estimate the acceleration when t is equal to 5. So t is equal to 5 here. We need to draw a straight line, a tangent to the curve. Just going to move that into the right place. A tangent at that point, and then we'll calculate the gradient of the tangent. So let's find 2 points on our line, on our tangent. I have, so it's 16, 17, 18. I've got 0, 18. That's a nice point. And 5, 6. So 0, 18 and 5, 6. Let's go with those. So the gradient is the change in y divided by the change in x. So the gradient, and let's have x1, y1, x2, y2. So the change in the y's, I'm going to do y2 take away y1 over x2 take away x1. Negative 12 over 5, which is negative 2.4. So the acceleration is negative 2.4 meters per second per second. And again, there'll be a range of answers for this one that are acceptable. Work out an estimate for the distance the car travels in the first 6 seconds using 3 strips of equal width. So this time we are working out the area under the graph. So the distance travelled on a velocity time graph is the area under the graph. We're using 3 strips for 6 seconds. So we're going to have a trapezium for 0 to 2, another trapezium for 2 to 4, and another trapezium for 4 to 6. So we need to work out the area of these trapeziums. So it's half the sum of the parallel sides times the distance between them. So we've got 25 and 16 for our first trapezium. So it's half of 25 plus 16 times the distance between them, which is conveniently 2 seconds. So half times 2 cancels out. We've got a calculator we can use, but that is 41. For the second one, it's half of the sum of the parallel sides, which are 16 and 9. 16 and 9 for the second one. So half times 2 cancels out. That just leaves 16 plus 9. And for the third one, we've got 9 and 4. So half of 9 plus 4 times 2 is 13. So the total area is 41, 25 and 13. Let's use the calculator. 41, 25, 13, 79 meters. Question 15. Given that a is a prime number, rationalize the denominator of this. Give your answer in its simplest form. So whenever we have a square root plus something on our denominator, to get rid of it, we multiply by the same square root minus that something. And whatever we times the bottom by, we times the top by the same thing to keep it the same. So we're using the difference of 2 squares to cancel out our middle terms of our expansion. Let's just do it and we'll see why it works. So for the top, we've got 1 times root a, 1 times negative 1, minus 1. For the bottom, root a times root a is a. Root a times negative 1 is negative square root a. 1 times root a is plus root a. And you can see they're going to cancel out. And then 1 times negative 1 is negative 1. So the minus root a plus root a cancels out. So we've got root a minus 1 over a minus 1. So it's in its simplest form, we have rationalized the denominator. We've no longer got a square root on the bottom. 16, solve. So it's already factorized. We don't need to expand it. We just need to solve it. So where is this less than 0? I can tell you where it's equal to 0. That's what makes the first bracket 0. X would be 3/4 to make the first bracket 0. X would have to be negative 5 to make the second bracket 0. So 3/4 and negative 5 makes it equal to 0. What makes it less than 0? So for a positive quadratic, if it crossed at negative 5 and at 3/4, it's got a shape like this. So it's equal to 0 at these 2 points. It's bigger than 0 up here. It's less than 0 down here. Underneath the x-axis, that's where it's got a negative answer. So what makes it less than 0? Anything in between negative 5 and 3/4. Question 17. It looks like we've got a similar shapes question. L, M, and P, three similar solid cylinders made from the same material. So we've got a mass of L and M. So the scale factors for mass are going to be the same as the ones for volume. Then we've got surface areas of M and P, and we need to know the ratio of their heights. So for volume, or for mass, L to M is 64 to 125. Now they're cube numbers, which is useful because the scale factor for volume is scale factor cubed. So if we cube root that, the cube root of 64 is 4. The cube root of 125 is 5. So the ratio of their lengths is going to be 4 to 5. For M and P, we've got area. M is 144 to P, which is 16. The scale factor for area is scale factor squared. So to go to the lengths, we need to square root. Square root 144 is 12. Square root 16 is 4. I can even simplify that to 3 to 1. So then we've got lengths. We just need to get these ratios together. So L to M is 4 to 5, and M to P is 3 to 1. To make them into one ratio, we need the M's to be the same. So I'm going to times my L to M by 3 and my M to P by 5 to make both M's 15. So that will be 12 to 15 and 15 to 5. So now I can just put them together because M's the same. 12 to 15 to 5. There are only 3 reds counters, 3 yellow counters, 1 green counter in a bag. Tony takes at random 3 counters from the bag. Work out the probability that there are now more yellow than red in the bag. What would Tony have to have taken for there to be more yellow than red? So he couldn't have taken any yellow counters. Otherwise, if he'd taken a yellow counter, yellow will be down to 2. There'll be no way of having more yellow than red. So we could either take all 3 reds, or we could just take 2 reds and a green. So it can be green, red, 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 green, red, or red, red, green. So they are the 4 options, which would mean there are more yellow counters. So we just need to work out the probabilities of these and add them together. So the probability of getting 3 reds, so there are 8 to start with. So it's 4 out of 8. If you take the first one red, there's 3 reds left out of 7. And then if you take the second 2 reds out, there's 2 out of 6 left. The probability of getting a green, then a red, then a red is 1 out of 8 times 4 out of 7 times 3 out of 6. And I'm just going to work out these two. So 4/8 times 3/7, the calculator will simplify it for us, times 2/6 is 1/14. And 1/8 times 4/7 times 3/6 is 1/28. Now, red, green, red and red, red, green are going to be the same as green, red, red. I can show you why. So the probability of red, green, red. So the chance of getting a red first is 4 out of 8. then a green second, 1 out of 7, then a red third, 3 out of 6. And you can see on the top we've got 4 times 1 times 3, which is the same. And on the bottom we've got 8 times 7 times 6, which is the same. And the same for red, red, green. It'll be 4/8 times 3/7 times 1/6. And you can see the 3 numbers on the top are the same. The 3 numbers on the bottom are the same. So in total, we want 1/14 plus 3 lots of 1/28. So it's 1/14 plus 3 lots of our last answer, 5/28. Question 19. The diagram shows quadrilateral OACB. M is the midpoint of O to A. N is the point on B to C, such that B to N is 4 parts out of 9 in total, and N to C is 5 parts out of 9 in total. O to A is called A. So we've got half an A to M, and then half an A from M to A. O to B is called B, and A to C is some multiple of B. Express M to N in terms of K, A, and B. So to get from M to N, we are going to need to know what B to C is. So B to C, we need to go the long way round. So it's going to be negative B plus A plus K times B. And B to N is going to be 4/9 of that. So B to N is 4/9 of minus B plus A plus K times B. So now I can go from M to N. I can go from M to N because I know what everything's called. I need to go minus half an A plus a B plus B to N, which is 4/9 of minus B plus A plus K times B. I need to give my answer in its simplest form, so I've worked out how to get there. I'm just going to simplify now. So I'm going to expand the bracket. So 4/9 times negative B is minus 4/9 B. 4/9 times A is 4/9 of A. And 4/9 times KB is 4/9 KB. I can add my A's together. So I've got minus a half plus 4/9. So minus a half plus 4/9 is minus 1/18. So I've got minus 1/18 of A. I've got B minus 4/9 of B, which is going to be 5/9 of B. And I've also got 4/9 of KB. And I can't really simplify it anymore. I could take fractions out, but I'm going to leave it as that is my answer. So minus 1/18 of A plus 5/9 of B plus 4/9 of KB. Part B, is M to N parallel to OB? Give a reason for your answer. So we've just worked out M to N. O to B is B, just called B. So to be parallel, it would have to be a multiple of B, but it's got an A component, so no. No, M to N has an A component. It is not a multiple of B. Question 20. The curve C has equation y equals 2x squared minus 12x plus 7 find the coordinates of the turning point on C. So to find the turning point, we can complete the square. So we've got a 2 in front of our x squared. We don't really like that. I'm going to factorize it out. So I'm going to take 2 out of this equation. It's going to be 2 times x squared minus 6x. I could either leave the 7 or also put it in here. So half of 7 is 3.5. So I've taken the 2 out. I'm now going to complete the square on the bit inside the bracket. So I'm going to do a giant bracket. To complete the square, we half our b, half our coefficient of x. So half of -6 is -3. It's going to be x minus 3 squared. I'm going to take away 3 squared, so take away 9. So x minus 3 squared minus 9, that is exactly the same as x squared minus 6x. If we expanded it and simplified it, it would get us back to x squared minus 6x. It's just a way of rewriting it. And I've got plus 3.5 as well. So that's 2 times x minus 3 squared. I've got -9 plus 3.5, which is minus 11 over 2, or minus 5.5. I can now expand this again. This is just one term, so it's 2 times that, and then 2 times minus 11 over 2. So it's 2 times x minus 3 squared minus 2 times 11 over 2, which is 11. So that's completed the square. So this is exactly the same. This is exactly the same as my equation. It's just in a rewritten form, which tells me the turning point. So the turning point is when the bracket is equal to 0. That's when x is 3. So when x is 3, the bracket's equal to 0. 2 zeros are 0. What's left? Y is -11. So the turning point is at 3, -11. The graph shows y equals g of x on the grid. So there's y equals g of x. On the grid, draw the graph of y equals g of minus x plus 2. So there's 2 things we need to do, 2 transformations. The minus x inside the brackets is going to flip it over the y-axis. All the positive x's are going to become negative. All the negative x's are going to become positive. And then it's plus 2 outside the bracket. That moves it up 2 spaces. It adds 2 to all of the y's. So we've got 2 transformations, one for the x's. Positive x becomes negative, and then it has to go up 2. So here we've got 3, 1, the point 3, 1 over here. The positive 3 is going to go to -3, and then it's going to move up 2 spaces. It's going to move up to there. Let's pick another point. Let's pick the bottom point. So it's going to flip over the y-axis and then move up 2 spaces. And this point here, it's going to flip over the y-axis and move up 2 spaces. So we can see the shape is forming. It is going to look like this. So it's flipped over the y-axis and moved up 2 spaces, or moved up 2 spaces, flipped over the y-axis. Question 22. A and B are points on a circle, center at the origin. MAP and NBP are tangents. Prove that A to P is equal to B to P. So it's a circle theorems question. Whenever we've got a tangent, it meets a radius at a 90-degree angle. So it's a proof question. Let's write down our steps. So OBP and OAP are both 90 degrees because a tangent meets a radius at a right angle. This is going to be a congruent triangle. So we prove the two triangles are congruent. Therefore, we prove that B to P must be equal to A to P. So why are they both congruent? O to P is common to both. Common to both triangles. O to A is equal to O to B because they are both a radius. And O to P is actually the hypotenuse. So what are our rules for proof? We can have all three sides, a side, an angle, and a side, an angle, a side, angle, or a right angle triangle, the hypotenuse, and one other side. So we've actually got a right angle triangle, the hypotenuse, and one other side. So because of the RHS rule, triangle OBP and triangle OAP are congruent. They're exactly the same. Therefore, AP is equal to BP.